Hi everyone, welcome to Frontline Systems webinar on data mining using XLMiner platform, our advanced product for building predictive models. My name is Dr. Seema Maliki. I am consulting lead and modeling specialist at Frontline Solvers. During this presentation, if you have any questions, please feel free to type them to the chat box. Our marketing director has joined us today, and he will reply to your questions. And if you have any other questions that relates to XLMiner, I will answer them by end of webinar. Almost every action in your business generates data. Your sales transactions, customer interactions, even clicks on your website. This data can be a valuable strategic asset when used in your decision making. And this is accomplished with data mining. Data mining allows you to find and extract useful information and discover patterns from your large data sets. XLMiner is a powerful tool available to you to gain insights from your data via data exploration, visualization, forecasting, and data mining in Excel without any need for programming. And this is a time saver to help you get valuable results quickly. Of course, we have other products that allow you to do programming, like XLMiner SDK, which gives you other features, and we also have web-based products, cloud-based products called XLMiner.com, available at XLMiner.com webpage, which we are going to talk about more. Today, we explore how XLMiner platform can benefit you and how easy it is to use. Together, we'll review typical application, including visualization, classification tree, boosting ensemble methods, text mining, and we also review one example of time series forecasting. Just a quick review of some useful information. In data mining, we pay attention to each type of variables. Your database may include gender variable, which can be recorded as male or female. Sales variable could have high, medium, or low values. So these are a couple of examples of categorical variables. Every unique value of a variable is a separate category. And then another type of data is numerical, such as money, age, or any other continuous variable. In general, we have a total population, and then we have a sample. And a sample is normally drawn as a random sample to ensure that it is a statistical representative of the whole population. And then we partition the data into training and validation set. The training sample is used to train the machine learning model, and the validation set is used to evaluate the model performance. Imagine that you have a data mining project. What will be your key steps? Here you can see some general steps that apply to any project. Sort of things that you should keep in mind. First, you identify a problem you want to solve or an opportunity you would like to leverage, and you have a question. So you want to predict a fair market value for a house, or you want to predict how many units of your product a customer will purchase in the future. Or you want to classify whether an online transaction is fraudulent or not, whether an email is a spam or not, or if an insurance applicant is a high, medium, or low risk. So this is just the first step. You identify the problem or opportunity. Then you collect your relevant data, which is the data discovery stage. After that, wrangling, shaping, and cleaning is the first step. You need to understand your data and use exploration and preparation. Preparation step can include handling your missing data, binning your continuous data, or transforming categorical data when there are too many categories and you want to group them into fewer categories. You might want to find columns of variables with more predictive power. Then you can use visualization along with feature selection. All the examples we're going to review today are nice, they're already shaped and clean, but the real data tends to come in where you have to deal with mismatches and you have to do more cleaning. XLMiner is one of the tools you can use to deal with that. You can easily delete a row because it has a missing value, or you can insert the average value, or you can do much more in order to clean your data, and it has all other features available to you. And this is usually the most time-consuming stage. Next, based on your project needs, you can identify the best data mining approach. You can test various machine learning models and evaluate their performance. Now, one quick note: to avoid overfitting problem, we always partition the dataset into training and validation set. And why we do that? If you don't, you will fall into trap of overfitting. That means that the machine learning model has fitted the model so closely to all of your specific data, the particular cases that you presented, that it doesn't generalize very well. So when it sees future data, it makes more errors that you would really like. To minimize the risk of overfitting, you always want to partition your data set. Hold out a sample for validation and train the model on part of data and validate on another part of data. Now, in Excel, in general, we have supervised and unsupervised learning algorithms, and in XLMiner, we have unsupervised learning algorithm available, such as clustering, principal, components, feature selection, association rules. And these kind of algorithms, they do not seek to predict an outcome, like market basket analysis or social network analysis. Now, we also have supervised learning algorithms available. In supervised learning algorithms, our goal is to predict an outcome based on a set of features. The outcome is generally referred to as a dependent variable, response, or target. The features that are used to predict the outcome are referred to as inputs, predictors, or independent variables. Supervised learning includes classification and prediction methods. Predict enables you to identify a value for a continuous outcome, such as predicting the fair market value of a house or how many units of product your customer will purchase. Classify allows you to predict a discrete categorical outcome, such as if an online transaction is fraudulent or not, or if an insurance applicant is a high, medium, or low risk. Now we're ready to walk through XLMiner features, starting with get data and data preparation features. So I'm going to switch to Excel. Here is the full analytics solver platform ribbon, which includes XLMiner platform. Analytics solver platform is our comprehensive product, including optimization, simulation, and stochastic optimization, risk analysis, decision trees, and so on. And it also includes XLMiner, but you can have access to XLMiner as an individual product. First thing in the ribbon, you can see there is a model button. Clicking on the model displays or hides this task pane in the right side. Then we have get data. This is the sampling tool in XLMiner. It allows you to bring data into Excel and allows you to draw a statistically representative sample of data from another worksheet with any other databases such as Microsoft Access, SQL Server, Oracle, Power Pivot. You can bring in data from file folder. We discussed that more during text mining. And you can bring in data from Apache Spark Big Data clusters. You can easily get a sample. You can connect to available databases, and you could also have your own database loaded there. We use Amazon Web Services. You can select different variables. There are different options. Since these databases are really huge, they are spread across multiple hard disks, and we're over the internet. We're getting just a fraction. You can see this is determining the size of fraction for us. But you can adjust all the settings. and you can select the different variables of these data sets. For example, I just want to show you quickly how you can run the algorithm very quickly, and just get a fraction. We run to bring this sample of big data into Excel. You don't need to program. This sample will be in Excel, and we can just use it for further analysis. Here's the sample, a fraction of that data set. That data set has 120 million rows of data in our purchase for big data cluster. And this is just a sample ready for further analysis in Excel. Now, next we have the data analysis group. Explore tool allows you to visualize your data and provides you with feature selection capability. With XLMiner chart wizard, you can create 8 different types of charts. Simple bar and line charts, scatter plot matrices, and parallel coordinates. And these are some charts available. Some of you might like to work with Power BI and more advanced just visualization features such as Tableau. And to make this easy for you, we have export to these features available. So when you build, you have a data set, you can easily use these features to export to Power BI or Tableau. Next, we have the transform or data handling utilities of XLMiner. Again, this includes missing data handling, transforming continuous data, categorical data, and principal components here, but that's part of a unsupervised learning algorithm. You can see text mining. We have building time series analysis tools. It includes the capability to partition a time series data, the ability to fit a model using array with or without seasonal components, and 4 types of smoothing techniques. Then again, we have partition in the data mining group, and I will discuss in the time series analysis example why we have a separate partitioning for time series data. So this is for just regular data. We have standard partition with oversampling. We have 10 supervised learning algorithms, including 6 classification models and 4 prediction algorithms. And we also offer ensemble methods for regression tree, neural networks, and classification tree and neural network that allow you to build better models. And we'll discuss more when we run an example how they can help us. These are ensemble methods. And we have 4 unsupervised learning algorithms, 2 clustering methods, association rules, and we talked about where the principal components is here. And there are also feature selection. You can score your new data here or within an algorithm, and in the help you can have access to examples, user guides, reference guides, and much more. Okay, now let's start with opening one of the example data sets. So click on Help, Examples. This set of examples are available when you download any of our products. So we can go to Monte Carlo simulation examples, optimization examples, or forecasting and data mining data sets. For this example, let's look at the wine data set. This data set includes information about wine with 13 variables that describe different properties of wine from 3 vineyards. We call this vineyard type A, B, or C. So each row is a wine sample. We know, for example, first row is a sample from vineyard A. And we know this specification about this sample of wine. Our goal here is to assign a wine classification to each record. So I'm going to build a classification model, and in future, if I have some new samples which I don't know whether they belong to vineyard A, B, or C, I can use that built model and classify this new data and find out whether that sample is from vineyard A, B, or C. Let's first use Chart Wizard to see what it shows. So select the cell within the data, go to Explore, chart wizard. Now automatically it recognizes the dimensions of your data in this section. Let's use a scatter plot matrix. Let's click on next. Here we have all the variables or each column name, and let's select a couple of them. Let's do 5 and click finish. So this is the scatter plot matrix. On the diagonal, we have histogram of each individual variable, and on either side, we have the scatter plots showing the interaction between each two of the variables. Some of the features that are available here to you. For example, in third row, I can see this cluster of data, and I can select these data points with my cursor, then they immediately turn red. Not only in this chart, but in all other charts. And what you can do is just look to the right for individual records. It seems that most of them belong to vineyard type C. We have other filters available to you here. Now we can remove the selection, go to color by, and color by our type variable or vineyard type. And now we can see that most of those were purple, which belong to vineyard C. You can see that based on some of the variables, we can get a relatively good separation, but we cannot easily draw a line to classify each record, whether it belongs to vineyard A and B or C. So this visualization is just helpful. You can do much more, add different charts. For example, add a new parallel coordinate chart. You can copy it, save it, and so on. There are settings here. Now, if you close the chart, you have the option to save it, chart 1. And when you save it, you can access it from Explore Existing Chart. So, since the visualization is not enough for our purposes to draw a line to classify each record as to which vineyard it belongs, let's move on to building a classifier model. This model would automatically look at this data and fits a model to indicate which vineyard the wine comes from. So let's use classification tree algorithm. Again, select the cell within the data, go to Classify, Classification Tree. For classification tree, we have three ensemble methods available. Let's first use the single tree, just a regular classification tree algorithm. Type is our category variable, it's our output variable. This is the wine type which we are going to assign to each of the records. And then all remaining variables are our selected variables. Now let's click on Next. Here we have the option to partition the data, again to avoid overfitting problem. Let's check partition. This is called partition on the fly. You could also use the partition on the ribbon. You can prune the tree using the validation set. Let's click on Next. There are multiple other options for tree growth. All of them are discussed in our user guide. To save time, I'm just going to skip discussing the details. You can check to see the full tree and best prune tree. If you have new data, you can score it now, or you can score it using the score button on the ribbon. And now let's click on Finish. Here are the results of classification tree algorithm. We have the output navigator helping you to quickly go to different sections of the results. Let's first look at the full-grown tree. Here's our full-grown tree. This is the prune tree based on the validation data set. So some of the extra branches has been cut. So let's look at the prune tree. Proline is one of the features of the samples, or one of the columns of data. Now, let's read the rules of this tree. If you hover over proline, it says, go left if proline is less than 730. So if proline is less than 730, we go to the left side. Now we have the next variable. if color intensity is less than 4.09, proline is less than 730, we know that sample belongs to vineyard B. In the same situation, if color intensity is greater than 4.9, the sample belongs to vineyard C. And then in the right side, for samples with proline greater than 730, we have used total phenol. And then it shows that if total phenol is less than 2.05, belongs to vineyard C, or if it's greater, it belongs to vineyard A. Full tree is a little bigger because it's used training data. Now we can look at other summary reports. For example, let's go to confusion matrices. This is the confusion matrix. It displays counts for cases that were correctly and incorrectly classified in the training and validation data sets. So this is the training. You can see we have actual classes and predicted classes. For class A, all the cases were predicted correctly. For class B, we have one mistake. So here you can see total error report. Overall 107 cases, one error. Percent error 0.93. Now let's look at the validation data set. There were 10 cases misclassified, resulting in a percent error of 14.08. So here's one of the ways you can compare the results. We also have visualization features available, some charts like ROCC curves, and you can access those when you get a detailed results. Now let's compare a single tree results with those from classification tree ensemble boosting method. But what are ensemble methods? Let's quickly talk about ensemble methods. An ensemble is a technique for combining multiple weak learners in an attempt to create a strong learner by taking a weighted vote of their individual classifications or predictions. And these methods can help us build better classification and prediction models. And they're available, 3 of them are available in our software. And they're offered for neural networks, classification tree, and also for prediction algorithms. So let's go back and apply this to our data set. So let's go back to our data, go to classify, classification tree boosting ensemble method. XLMiner automatically selects the variables. Let's click on next. There are 3 different variations of boosting algorithm available. The difference is in the way in which the weights assigned to each observational record are updated. Number of weak learners is default value of 50. Here, a weak learner is a single classification tree, just like the one we built. So this will tell XLMiner to construct 50 different classification trees during the run, train each one on different subsets of data, and combine the results to get a better classification. Let's partition the data. I'm going to keep other default settings. And let's click on Finish to run the algorithm. Here are the details of boosting ensemble method. We have the weights assigned to each weak learner from 1 to 50. We have importance percentage for each variable, measuring the variable's contribution in reducing the total misclassification error. And now we can look at the confusion matrix. For training data, total error is 0. So no records were misclassified in training data set, and only 4 records were misclassified in the validation data, resulting in a percent error of 5.6. As we can see, the classification tree ensemble methods are very powerful and they typically result in better performance than a single tree. Now I will quickly talk about feature selection before moving on to text mining and show you what it can do for you. Feature selection helps you identify which of all the hundreds of your variables or columns of data have the most predictive power to feed into your classification or prediction algorithm. So in this data set, we have a few variables. But imagine you had 100 of variables instead of just 13 or 14 variables. A lot of your variables are going to overlap each other. Some are going to be important, some may not. You can use all of them in your classification or prediction algorithm, but it is going to take lots of time. And feature selection is a preliminary step, just like visualization, that you can use to quickly find out which variables are most significant and then concentrate the rest of your analysis on those. So we have this category called variable type. Let me show you what feature selection can do here. Click on Explore Feature Selection. So we want to find out which of these variables are most important or have the most predictive power in classifying the type of each sample. So let's select all the variables. Continuous. You can see the output variable type is categorical, so feature selection knows that I want to do a classification later. Now we have the option to select different statistical filters to compute F-test, Fisher score, and Gini index. Let's click on Next. You can have top features table. It gives you a report of most important variables. You can also access feature importance plus. I'm going to increment the number to cover all the variables. And we can rank by F statistic. You can select how would you like to rank. Now let's click on Finish. Here's the feature importance plot. This is a graphical representation of variable importance based on our measure F statistic. So you can see the variables in order of importance. And we can see that the most important variables are really flavonoids all the way to maybe total phenol. So just 3, 6, 7 of them. Or you can stop at color intensity and run the algorithm with only 5 of them. Or even with the most 3 important ones. So for example, let's test it with flavonoid, proline, and this OD280. And alcohol and color intensity. So let me show you one of the other outputs. I guess I have to go to Detailed Feature Selection Report. It's easier to find the results using the Output Navigator when you run multiple algorithms. Here we are analyzing the data using several different statistical tests of their importance. By looking at how different variables are ranked according to different tests, we can get an idea of whether those variables are consistently showing up as the most important or not. Then you can focus on those variables and inputs to a prediction classification algorithm. So we saw the results based on F statistics. So we can also look at Gini index. For Gini index, we can rank the variables sort them from smallest to largest, and see the top most important variables. So you can see proline, color intensity, alcohol, and OD280 and flavonoids are the top 5 most relevant variables based on Gini index 2. Gini index measures the variable's ability to distinguish between classes. The smaller the Gini index, the more relevant the variable. So At this point, we already have a lot of useful information about our variables and their relationship to our categorical type variable. We started with all the features, and now we know rather quickly that only 5 of them matters the most. Now we can practice creating different classification models, yet instead of using all the original variables, you can just use these 5 most important ones. We have limited time. I wanted to run this and show you that the error is like really similar to when we use all the algorithms, but I'm going to skip that. But you have access to this data set. Feel free to practice this and compare the results and see that this feature section is actually really helpful, especially if you have very huge data sets. So let's move on to text mining. XLMiner text mining tool allows you to process and analyze your unstructured text data so you can quickly and fully utilize the power of this data to enable better decision making. This tool can analyze text found in cells in a worksheet, fields in a database, or in separate text documents. Some applications of text mining include the ability to classify customer reviews as satisfied or not satisfied, to distinguish between which products have the least negative reviews, to extract topics of articles, or to cluster documents or terms. For this example, we are going to use text files from a well-known text dataset which consists of messages collected from 2 different internet news groups, autos and electronics. Text mining document data is available in the example files. You can actually click on it, text mining documents, and you have to save it and unzip the folder. I've already saved it and unzipped it, so I'm going to skip that. Let's go to XLMiner, open a new file, a new Excel workbook, and go to XLMiner platform. So let's click on Get Data. Let's click on File Folder. I'm going to get a sample of those files. So we're going to extract a sample of text files from File Folder. Let's navigate to where I have those 2 subfolders, autos and electronics. This is electronics. Let's change the file type to all file, select all of them, and import them to select one of them and click on this button to move them to selected files. Let's repeat the same steps to auto subfolder, change all files, change it to all files, Control A, selecting all of them, open, select one of them the left side in the file section, and then click on this button to move them to the right. Now, you can select the radio button, sample from selected files, and we can enter 300 for the desired sample size. You can keep the default settings. For output, we have 2 options, write file paths or write file content. I'm keeping the file paths, it's more clean. For file content, it will write the content of all those sample files for you. Here, XLMiner just records the file paths, and let's click OK. You will see what happens. Here's the XLM sample file. We have imported the text file. This includes the file paths, but not the content, as we expected. During the text mining, we actually read the files at those file paths. Again, name of this column is text_var. Now, let's select text_var, or one of the cells in this column. Go to text, click on text icon. Let's select the column text_var, move it to select the text variable. Now XLMiner can read all the text within all those paths during the analysis. Let's click to Pre-Processing tab at the top. Pre-processing eliminates common words, so text mining can focus on the words that carry the most meaning. You can keep default settings for stop words, stemming, and case normalization. Let me show you all of these lists are, you can customize them. Here, vocabulary reduction. We have stop words removal, a, about, above. These really don't add any meaning, so you can again customize this list. We have term normalization. Stemming really means that if you have driving, driver, and drive, it will cut all of them to their stem, driv, something like that. The minimum stem length is 2, and you can normalize URLs, email addresses, and so on. And then representation tab. Here, XLMiner will create a matrix of terms and their frequencies. If perform latent semantic indexing is checked, which is by default, XLMiner will extract concepts from a set of documents where a concept represents a cluster of words that tend to occur together in the text of different documents. XLMiner counts how many words there are occurring in each document. In latent semantic indexing, we convert that into a smaller number of concepts. We have output options. We can select to look at zips plot, script plot, and term scatter plot. And you can write the text mining model and click on finish. Pop-up charts will appear. Now, for example, we can start from the zips plot. The first term is right. Rank is 1, frequency is 149. The last one is technique, and then rank is 850, and frequency is only 6. So zips plot shows the most frequent words, and you can see the typical rapid drop in word frequencies. You can see commonly occurring words and then less commonly occurring words. Script plot shows the relative importance of extracted concepts. We have this term scatter plot. We can see there's concept 1, concept 2. Concept 1 is really a cluster of words like car, drive, system, auto, words that are often found to occur together. You can zoom in and look at the individual clusters too. You can change the concepts, for example, concept 14, and you can see that cluster of words migrate over in terms of their frequency toward concept 14. So let's minimize the charts. Let's look at different other outputs I want to point you at. We have TM, TDM, and we have TM, LSA, CDM. This worksheet is the concept document matrix. The concepts which appear in the columns act like numerical variables in your model, and the rows are documents which are the same as cases or observations. The concept document matrix can be used as input to any of XLMiner's clustering, classification, and prediction algorithms. Similarly, we have TM-TDM, the term document matrix. Same situation. Both of these matrices can be used in XLMiner classification, prediction, or clustering algorithms. For example, you can use a classification method to create a classification model using the concept document matrix or this term document matrix to classify new documents based on the text content, whether they belong to autos group or electronic groups. So we just saw just a brief introduction to our text mining. There is much more you can do. All of these are discussed in our user guide and reference guide. And this was just one quick example of how you can get some productive results from text. in the remaining few minutes, let's quickly talk about time series data and time series forecast available to you. We know that we have these different types of data called time series data. Time series is a set of observations on a quantitative variable collected at equal time intervals, usually. So every observation has a date and time on it, and they are, again, usually equally spaced intervals. The observations are usually numeric values, for example, stock prices, exchange rates, consumer price index, or unemployment rate are examples of time series. Because rows are ordered by time, we cannot take random samples of time series data. So we cut it horizontally, draw a line somewhere in the data, and take one part as our training and one part as our validation. So the key difference is that in the previous example, we built a model using the columns except the output column, and we predict or classify the output column. We did that for one data set. In contrast, in time series data, we are trying to predict forward in time to the next row or several steps forward in time. The columns in time series are independent, so we usually cannot predict across columns. What we can do is to predict next value from previous values, which is called time series forecasting, which is available in XLMiner. So we have smoothing techniques, ARIMA, and then different, we can cover standard and seasonal models. So let's go back to our data sets. Open one of the time series data sets. We use the air passengers. This data set contains the monthly totals of international airline passengers from 1949 to 1960. Here we only have time variable and a quantitative variable here, number of passengers that is collected over time each month. First, let's use Chart Wizard to explore this time series data, and which will help us to use a better algorithm. So let's go to Explore Chart Wizard. Let's use the line chart. Click on Next. Use passengers as a variable. Let's have observe months for x-axis and click on Finish. As it can be seen, this figure suggests that the data is non-stationary. It has a strong upward trend, and also it has a seasonal pattern. Therefore, forecasts of future values for this time series will be more accurate if they reflected this seasonal effect. So let's close this chart. Now we have some good information about this time series data. Let's go to partition on time series group. We have time variable, months, and we have passengers as variables in the partition data. I keep the default settings and click on OK. Here's our partition data. Select the cell within the partition data, go to smoothing. I'm going to show you Hofg-Winter algorithm. We have three options. Multiplicative is the right choice for this data set, but you can run the neutron or additive models, and you will see that multiplicative gives you the least amount of error. Time variable months. Passengers is a selected variable. Since the seasonality in this data set appears every 12 months, let's enter 12 for the period. Number of complete seasons should be 7. I keep the default settings for this test for this example for all the weights. You can produce forecasts on the validation by checking or keeping this default selection output options. Let's click OK. Here are the results. Different training error measures, validation error measures. Here the fitted model, and here's the forecasted model. Here on the left side you have the fitted model. And this is the time plot of actual versus forecasted value for our training data. And it seems they match up fairly well. But usefulness of model is really the forecasting, depending on how actual and forecasted values are in the time plot of validation. So let's look to the right for validation data set. It seems that multiplicative model captures the data very well. as the actual and forecasted values in the time plot of validation also match up fairly well. So this shows that this multiplicative model is a good fit to our data. You can explore to adjust those parameters and see if you can get a better chart or better outputs and reduce the errors. There's much more into Ensemble methods available, partial autocorrelation and autocorrelation. Unfortunately, we don't have enough time to cover that. So let's go back to our slides for a final recap. So this is just a summary of the key steps. Just keep them in mind. Don't skip the first steps. Start with a clear question. Get the data, wrangle, shape it, clean it. Find columns of variables with predictive power. Use visualization. Use feature selection. Then try multiple machine learning models. Partition your data and train the model and validate it and look at the results, see if it makes sense to you, and then try another algorithm. To validate and compare the results, you can check performance on training and validation sets. You can use confusion matrix. We have charts, lift charts, ROC curves. We didn't get a chance to discuss them again. User guide, reference guide, and some videos that are available in our YouTube channel. And always check the performance on the validation. That's most important. And then look at the results from the report. You can try ensemble methods of weak learners. This is multiple machine learning models trained on different data subsets. And this is often yields better results than single machine learning models, and then apply the best model to your new data. You can always use the score button on the ribbon, or you can score while you're running the algorithms. So every action in your business generates data which can be a valuable strategic asset for your decision making. Data mining enables you to find and extract useful information, discover patterns, and gain insights from your data sets. And this ability to use data intelligently is a vital skill for business analysts. XLMiner gives you all the tools you need to visualize and transform your data in Excel and apply supervised and unsupervised learning methods without any programming. So today we started with Analytics Hub platform, and then we use the XLMiner part of it. You can see that in the left section we have forecasting data mining, and you can use XLMiner platform or XLMiner Pro as individual products. We also have XLMiner.com or XLMiner SDK. Let me quickly show you that. This is the XLMiner SDK page. It allows you to use our API and use this languages such as C++, C#, Java, Python, and R. It's again a software development kit, and you can embed your data mining in your applications. We also have analyticsolver.com or XLMiner.com, and then you can switch to XLMiner platform. You can see it's exactly similar to what you have available in Excel product. This is our XLMiner for the web, and this is a cloud-based service available to you. It's subscription-based. You can start a trial. Let me share the links with you. This is the link for analyticsolver.com or XLMiner.com. And here's the Solver SDK platform. And let me share the link to our YouTube channel. So here is our YouTube channel with lots of demo videos on different features of XLMiner and all other products. Go to playlists or videos and you can explore it. Just feel free to download the trial version and contact us with this special number for webinar attendees, and let us know if you have any questions. You can reach me at consulting@solver.com. Thank you very much for your time and attention. We appreciate it. And let me know if you have any questions. Please feel free to type them in the question box on the right side, or contact me at consulting@solver with your questions. We look forward to future webinars with you. Please provide us with your feedback on topic suggestions and your questions, or if, any comments you have about this webinar. I trust it was helpful. Have a wonderful rest of the day. Bye for now.